Good afternoon, ladies and gentlemen. I have two honors. We're continuing our work on section 10.1, which has to do with adding, subtracting rational expressions. And so we're still to the part of the exercise set where we're just doing some simplifying. And so we're going to simplify the given expression. So what things have we talked about the last couple days in this course? What are a couple of things we've talked about?
The rational expressions.
Rational expressions, we talked about that. What kind of techniques of things did we review to look for and how to do over the past couple of days? We talked about synthetic. I don't know if we talked about that. We talked about the ones I'm looking for, and I know I'm asking you to read my mind. We talked about excluded values, right? Yeah, so x cannot equal something. So how do we find excluded values here?
The x's in the denominator is 0.
Yeah, so what we'll do is we'll take x squared minus x minus 2 and set this not equal to 0, and then what? Then something else we talked about was factoring, right? So if we find the factors of this expression here, of the denominator, what are those factors going to be?
X plus 1.
X minus 2. And so x, what are the excluded values for x? What can x not be? X cannot equal negative 1, and x cannot equal 2. And it was pointed out by a student in the class, Victoria, 7th period, that there's nothing about the instructions that relates to what excluded values are. And that's right. I mean, we looked at the book, and the book doesn't say anything about excluded values for this problem, but I want us to be in the habit of keeping track of them. And that's part of what we try to do as mathematicians. All right, very good. Let's go on to the next step here. So we're going to do our rewrite with our factored. So if we can factor our denominator, which we already have done, right? So you write x plus 1, x minus 2. And what are we going to do with this numerator up here? And what is going to be our common factor of our numerator up here? So negative 4 times. Yeah, or I had it like this. 1 plus x, right? And so now that's that.
That doesn't really matter, does it? So if you like write an x plus 1,
no, it really doesn't matter, and really I like doing it this way because what you're doing is you're more faithfully following the process, right? And now in the next step, if you want to, you can do this, right? You can rewrite it as this. And that doesn't really change things, but just makes it look a little better, right? And what next?
Divide it. So you guys cross out.
So these things will cancel out to equal 1, right? So what do we have left? We have negative 4 over x minus 2. And then that's going to be our entire simplification and keeping and understanding that these things up here are excluded values.
So then the answer would be like negative 4 over x minus 2, and then you have those to the side?
Yeah, kind of to the side, yeah. That's how I want to do it. Yeah. And then what I want to do is I want you to work on number 6. I'm going to call somebody for number 6 here in a couple, 3, 4 minutes.
As
know what you're doing on this?
Yeah, I'm starting to actually A. There's nothing, I hope I have
Yeah.
it completely, but I'm doing it.
That's all right, we'll just go see.
Writing X.
How do you like our debaters?
So I think we,
Did you do X plus?
the topic, so for the top, is it just decided? So then top of the same thing. Just go and just affect the.
Oh, okay. So that.
But just instead of this.
So they can.
Wait,
That's positive.
so I write exactly that. Wait, that doesn't make sense.
The top is negative. Negative.
Oh, wait, we have to
Use those.
distribute the, okay, we don't have
I'm just supposed to be closer together.
that.
I didn't have a
The
photo.
negative? Yeah, I was gonna say that. Would you say X minus 8? X plus 8? It's just X. No, plus.
Well, they couldn't.
Minus and plus is negative, so it'll be, so it's.
Okay, let's go choose somebody here, help us out with problem number
And then cross out the X.
6. And that person is going to be Jay or Julia. It's going to be Julia. All right, Julia. All right, Julia. What'd you get on this?
Yeah. I'm still in the middle of working now.
You're still working out?
Yeah.
Let's see what you have. Okay. So she's looks like she kind of just started on this, so we should need some help with it. Okay, first thing she did is she's taken these, she's saying x squared plus 9x plus 8 cannot equal 0, right? And so what are the factors of this going to be? What two numbers multiply together to be 8, but add together to be 9? Thank you, Julia. So you got x plus 8. So what can x not equal?
X can't equal -1.
Okay, x cannot equal -1, she says, and x cannot equal
Negative.
-8. So now we can rewrite this thing like this, right, like this. So you got x plus 1, and then x plus 8. Can we rewrite this thing up here? What is our common factor in here? So negative, so you have x plus 8 here, right? So what happens next?
Cross it out.
Cross out like this. So we end up with -1 over x plus 1. But x cannot equal -1. X cannot equal -8. Is that it? Is that right?
Yes.
That's right. That's right. Thank you.
So it looks negative.
So really, that's that one. That's it.
We got it though.
The best thing.
Okay, hello, next one. Oh, so much numbers. You could just
Okay.
distribute them. Cancel them all.
Now, Okay, next. What happens is, number 7 takes us to, we're going to simplify this, same type of problem. And this one here, the factoring is a little more complex. Should I choose somebody to do this thing?
I think you should do it.
You should do it.
That way we didn't examine it.
Yeah, you should do it, Mr. Jean.
Ben said it's easy, so he can do it.
No, but you can do number 12. I like that one.
You need your.
Ben, you want to do
You need
this?
your
He's
help.
halfway there.
I'll do it.
Oh, no. You can't take his name off the thing though, because he volunteered.
That is true.
Yeah.
You volunteer, that means you can do anything at all. That is true.
But I've really had some good students work this out. I had, last period, I've had Steve-O and
So Marcus should do it, that's what you're saying. Yeah, Marcus.
Steve-O and who else? Rindy. I think factored this out today earlier. Anyway, so a couple of our better Algebra 2 students in other classes worked on this.
Mark, you have to live up to your brother. Well, yeah, that's not asking.
Yeah, get it out, get it back.
You're gonna let your brother
That's
be
what I
better
have.
than you?
Back.
Yes, I would do that. He's the right math, I'm not.
Yeah.
But yeah, that's it. So let's take it easy on Marcus today. We'll give Marcus a little bit of a break. If I, look,
Yeah, I don't know.
I have a brother I went to college with who's very smart at math too. He wasn't smart, we were smarter than I was at math. We were kind of pretty much equal. But I can imagine if he were, that'd be tough to live up to, right?
Just have to beat him on the street.
Just have to beat up my brother?
That's right. Have a hard time, the smarter one.
I'd have a hard time doing that.
They can use that guy that you use to beat up little kids during the play.
Now you did.
Okay, Ben, what do you have?
Oh, okay, so you factor out the numerator,
Okay,
and you get 6x plus 1 in parentheses. And then you get x plus 1,
okay,
and then the denominator is 3x plus 1.
In parentheses.
And then, yeah, an x plus 1.
Wow. Okay.
okay. Anybody get something different in this?
Where do you get 5x?
Yeah, where did you get 1 and 1? So that does
On
not
the top
equal-
row, okay, so on the top one, that means the 2 1s are negative.
That wouldn't be.
Where do you get 5 out of 1 and 1?
Yeah, that's what I want to know. How do you get 4 out of 1?
How do you factor those out?
I'll show you in a minute. We're letting the process
I
take.
think Ben knows.
I think we should give it.
Oh, no, wait. Instead of 6x, it's 2x and 3x.
2x and 3x, okay.
Okay. That makes a
So-
lot more sense now.
So what Ben is telling us by seeing in real time, he's telling us that he sort of used a little bit of trial and error. Would that be safe to say, Ben?
Yes.
Yeah, we had it corrected.
Yeah, we corrected it.
Oh, that's good though, that's good. And I'm gonna show you, there are a couple of different ways we've done it. And one way, I'll tell you the way the other people did it in this class in Algebra 2 honors earlier today, is they used the box method. And I'm just gonna show you the first. By the way, this denominator is correctly factored. It's the numerator that originally wasn't. But using the box, one thing when you have, the box method is a pretty good way to go because what happens is the factors of 1 are going to be pretty obvious, right? They're going to be 1 and 1. So when you have a limited number of factors, then that's going to work out pretty well. And then so 6x squared will go here. And so now you're trying to find factors of 6x squared. And what Ben did originally is he did this, right?
Yeah.
And what's the problem with this?
You can only get equal 5x.
The problem with this is you get 6x plus x, so you'd get 7x out of this deal. And so you'd be able quickly to change gears, shift gears, and make this like 2x times 3x, right? And so now you'd have 3x here and 2x here, which will add up to 5x. So that's going to be correct factoring at this point, right? And then our excluded values are x cannot be equal to -1, and x cannot be equal to -1/3, right?
Right.
You see how I did that?
Yeah.
Because what here, if you have 3x plus 1 is not equal to 0, then you subtract 1 and divide by 3,
Okay.
you get. So what happens is, I sort of did this pretty quickly mentally, and I'm able to do that because of
Experience.
a lot of experience at it, right? Factoring and so forth. So anyway, these are the excluded values. And now, can we simplify now?
Well, is it just 2 values? 2 excluded values?
Yeah, because that's going to go ahead and make the denominator equal to 0.
Right, okay.
So those are 2 excluded values. All right, we can't have any more excluded values than factors exist in the denominator, right? Okay, go ahead. So now what's next?
So then you cancel out the 3x plus 1.
So that cancels out here. So you get 2x plus 1.
Over x plus 1.
And so this is going to be our answer with these excluded values. I do for factoring also want to just throw in, we've used the X method or bottoms up method where you have AC on top, so 6 on top, and then B on the bottom. And so what 2 numbers are we going to have here? 2 and 3, right?
Right.
And you divide by A happens to be 6, so you get 1/2 here, and you get 1/3 here. So if you have like x plus 1/3, and then x plus 1/2, here you bottoms up, and you get 3x plus 1, and then 2x plus 1, right? But before I got into the teaching business, is what I would do is I would factor these kinds of things out just by setting up parentheses and trial and erroring, kind of like Ben did, right?
The other ones would go with
All that.
it.
Okay?
Yeah.
So let's just go ahead and work on number 8.
We're gonna work on number 8.
Yeah, work on number 8, call on somebody. In my estimation, number 8's a bit different. It's this time I remembered to have my Mobi GU pad charged. I shouldn't run out today.
I got x plus 1, and then secant x plus 1.
What's the wrong one?
Call? You can get it. With this? That would be x squared minus 1. Yeah. Top would be x squared.
I don't know.
Then let me know when you finish, so you can check out work.
But I don't know. Why would it be plus and minus? That would be negative.
That'd be, Is this what you got? Then what you
So I
got?
have no.
I got a comment that.
That's all.
I got what you got. No, not this part. That part's wrong.
This part wrong?
Yeah, I got
This part, no,
It's A.
How's the bottom part?
Hopefully Connor got it. It won't be equal.
Hopefully got it.
Which part are you talking about?
Reduce it down, this is the problem is.
I have it written down.
You're doing good.
I think this is right. Okay, look.
We're all
I'm gonna get it written
That's
down.
exactly
I
what
know
did.
it. Yesterday she did, she's like.
Yesterday when you were in the bathroom, I got thinking
Because like,
She goes, I
I
know
said,
the first one. Yeah, I was like.
it's a wood.
So the one part's 1
Watch, I'm gonna
Then
be
one
there.
x plus one x.
And I only have one little thing written.
It-
I don't get it for sure if it's right.
Yeah.
Not equal to that.
Don't do that one. Don't do that one.
Just in
Negative.
case.
No, no.
Okay, ready to go? Ready to go on number
No,
8?
you're gonna win.
I was late. I was late.
We'll be there in about 10 minutes.
Okay, I'll wait just another minute.
Negative 1 times 2
Hopefully, like,
is.
Pointless.
Negative 2. Oh, it's gonna be a trinomial.
Goodness.
You just do all it is.
Vin, I think you're wrong.
So you just leave it on the bottom.
Yeah, I think so.
Wow, look at that.
Oh, yeah.
Yeah.
X squared minus 1.
Back up, guys.
Minus 2 here.
No, not one. I mean, not two, one.
Check this, I got my calculator.
Cam, what's so funny?
What?
Cam,
Hey, Kim, that's enough?
Cam,
Really?
gotta let us in on the joke. I wanna laugh like you're laughing.
Exactly, Mr. G. That's what I'm saying.
See, that doesn't seem like you.
She's having too
That's
much
not right,
fun.
Ben. Ben, that's not right.
I wanna be having fun too.
Ben, you're not right.
If I get picked, I won't.
There's no way.
Yeah.
There's no way. Mark out the same thing, will you?
Yes.
Well, that's me.
Go ahead.
No, you might have the same
You
thing.
said laughing.
Well, let's see.
Okay, so
I
there's
just looked at you, so it's like.
Okay.
Okay,
Red line math is it.
okay, let's go here. We're gonna go now.
The red line's not even.
Oh!
Yeah, we got it.
Here we go.
Okay, when do you have to factor that out?
Wait, so what's the two that you can't use?
X can't equal 0.
Oh my goodness.
Oh!
What did I do?
Ah, that doesn't.
Oh!
Mr. G. Mr. G.
No.
Okay, I have,
Okay, class, let's be quiet, let Addie talk a little bit, please, thank you.
all I have is x squared plus 1 not equal to 0.
The new girl did.
And then I tried to factor it, but I was confused.
Okay, so we'll start here. This is a good place to start. I appreciate you starting us here. Let's go ahead and solve this, right?
Yeah.
How do you, so try to factor is, you can't factor left side. So we have x squared is not equal to negative 1. Did everybody see that?
Oh, okay.
Right?
I told you you were wrong.
And then what are you going to do next to solve for this? You have x cannot equal what?
Nothing.
Square root of plus or minus square root of negative 1.
Imaginary number.
And what is square root of negative 1?
I.
I. So x cannot equal
I.
plus or minus I.
Concerns to being serious.
So we're talking about an imaginary number, right? And so what does this tell us?
That we are safe.
This tells us no excluded values.
We're safe from excluded values.
Yeah. So here's what it is if you think about it, is there any real number that x can be that makes the denominator equal to 0?
Told you.
No. So no excluded values, so we don't have that to concern ourselves.
Okay,
So what's the
wait,
next step?
Okay, so that means the no extended values means like there's no thing where.
That means there's nothing that X is not.
There's
Okay.
no excluded value.
Yeah.
Yeah.
No values are excluded.
Like no
Sorry, guys,
value
I'm
is
a-
excluded.
No,
No values excluded. No value left behind. Let's put it that way, right?
Okay, that makes sense.
Does that make no value left behind? Okay. Okay, Addie, what next?
There's a next step.
Yeah. And what it is involves the numerator.
Do you have to factor out the numerator? Can that be factored or not?
Yeah, how do you know it can be factored?
Because x squared and x squared equals x to the power of 1.
So let's go ahead and put x squared, right?
Okay.
And that's a different square, so we have plus minus, right?
Yes.
And plus minus what?
1.
1. So what happens now?
You can cross out x squared plus 1.
So what do we have?
X squared minus 1.
Minus 1. Yeah. Can we factor that further?
No.
Yeah, we can.
Yeah.
But do we need to factor further? Do we need to factor? Because we could write this as x plus 1 times x minus 1 if we wanted to. That's not going to help us, right? So really, we're at to the end of this trail here, right? Right.
Oh,
So Addie was kind of put on the spot here because this was a little different problem, wasn't it?
good job, Addie.
Back on the rule.
Do a round of applause for Eddie.
Very good. Did you all work last year on, or ever on imaginary numbers? Remember imaginary numbers? And it's really weird, because that's one thing that, in my classes, I don't like to talk about it very much. And it's one thing that Mrs. Calkins next door in her Algebra 2 class will talk about imaginary numbers quite a bit. I don't very much. One reason I don't is because in calculus, at least the one that we're not dealing with imaginary numbers very much. And so I'm really, my preference is not to spend a lot of time at it, but except stuff like this, it comes up. Also, when you solve a quadratic equation with where your discriminant is less than 0, you'll have imaginary numbers out of that. But we won't be doing that. So we have a lot of mirth going on in the classroom. First it was Kim and Addie, and now it's these guys here. I don't know what it is. Something's happened. The guys are in good mood, I guess. That's fun. Okay. So next we go to this one right here. Add or subtract given expressions, simplifying each result, noting the combined excluded values. And so what I'm going to do is I'm going to try to go over with you on number 9. Just so, what do you think we're going to do first on number 9?
I think the denominator is the same.
Yes.
Cross multiply.
Make it.
The first thing I'm going to do is I'm going to find the excluded values,
Okay.
right? Because that's part of the instruction set this up. So what are our excluded values?
0 and -1.
Yeah, so x cannot equal 0, nor can x cannot equal 0, nor can x equal -1.
Why can x not equal those numbers?
Because it's the denominator. You can't include 8 on it. Okay.
Oh, okay.
That's one thing about this class, you guys pull no punches. It's kind of cruel. There's not a lot of mercy going on here.
Oh, no. What's mercy?
We need to,
Mercy's for the weak.
well, oh my gosh. I think I need to pull out some Bible. We need to relearn here, I don't know, Matthew, what is it, chapter 3 through chapter the Beatitudes and all that. Blessed are the merciful. Blessed are the merciful, for they shall receive mercy.
Cobra Kai said no mercy, so, I mean.
That's not how it works.
Do we need to get Pastor Leva up here? We probably do. Right? Pastor Leva, come up here. Yeah. Would Pastor Leva say something like that?
What about Beebe?
Pastor Beebe.
He's in this.
He's a pastor.
Yeah, he's like right there. You want to go get Pastor Beebe?
He actually could probably help sometimes too, yeah.
Probably.
Yeah, I'm sure he'd be very qualified too. All right, very good. So anyway, we have our excluded values here. You understand why we have them. The next thing we're going to find is what?
Common denominator.
We're going to find a common denominator, which I'm abbreviate called the CD. What's our CD going to be?
Negative? No, not negative.
How do you always find a CD? How can you find a
Make a
CD?
good guess.
You find the
I'm just kidding, that's a joke.
You
Solve.
Okay, you can always get a CD by multiplying the D's together. Okay?
Okay, that makes sense.
So if we multiply x by, I'm going to put x plus 1. I'm going to kind of change the
Right.
orientation a little bit. So this is our CD. Does everybody see why that's our CD?
Yes.
Is that because you like?
If you multiply the denominators.
Yeah.
Yeah.
So you can always get those, but, so what we're gonna do is rewrite this one here.
Okay.
So I have 1, and I'm gonna just change this to x plus 1, and I wanna get this with this as a common denominator. What do we have to do to get this to this common denominator?
Multiply by x.
We have to multiply the denominator by x, and we multiply the denominator by x, we also have to do what?
Multiply the top.
Multiply the top by x. Who said that over there? Yeah. Very good, good work. And so we have, so now we've common denominatorized this left fraction. Common denominatorized. Is that a
I
word?
love that word.
Yeah, okay.
Denominatorized.
Okay, so next we have 1 minus x up here over x, and how do we common denominatorize this guy here?
Multiply by x plus 1.
X plus 1, and x plus 1 here. And so we got to multiply the whole thing. And so now do we have a common denominator? Yes, we do. We have x plus 1 minus x times x plus 1 all over x times quantity x plus 1. And so what's the next step here?
Cross it out. Cancel.
Well, you cancel where you can, but before we do that, we're going to do what with this guy here?
Make it to 1.
We're just gonna expand all that out,
Expand it, yep. Like ice.
Okay.
right? Expand out. So we have 1 minus x times x plus 1, and so we have 1 times x. We have x times negative x. So that's negative x squared. We got 1 times 1. That's 1, and we got 1 times negative x. We got negative x. These guys are going to cancel. So all we have is x squared, this just stays, and this stays, right? Everything else is canceled. So we have is negative x squared, and we have plus 1, but also we have plus x, and then plus 1, right? Or is it, yeah, it is plus 1. Because that's 1 times 1, yep. Plus 1, and that's all over x times x plus 1. And these are the excluded values that we carry with us. And that, ladies and gentlemen, of Algebra 2 honors, that's worked out for today. Okay, then we're going to resume on number 10 tomorrow, okay? We'll just leave it right there. Thank you.